Hello and welcome to another one of these ADD videos. Today we're going to be looking at the concept of exponential functions. We're going to start out by looking at the graphs. If you can keep in mind the fact that logarithms and exponential functions are inverses of each other, it'll help you in the graphing process. Because if the graph of ln of x has an asymptote at x equals 0, then by that rationale, y equals 0 should be an asymptote and horizontal for the exponential graph. The intercept for the logarithmic graph was 1, 0, and it was an x-intercept. So here we have a y-intercept that's 0, 1. Okay. This holds true for any number including e to the x, because e is 2.718. However, if we have a negative exponent, or a 1 over a number to the x, however you want to look at it, because the negative exponent tells you to bring it down to the denominator anyway, make it positive. That's going to be a reflection about the y-axis, and it's going to be a descending graph going through the same y-intercept and having the same horizontal asymptote of y equals 0. So, knowing those two basic functions, you can apply the transformation rules that you should already know by now and check out the practice problems with graphs. But you might be asked to do some same base problems. Basically what you do with these, your goal is to get the same base. Alright, so what you got to do is you ask yourself, can you write these two numbers right here as some number raised to a different power? Okay, it has to be different because they're not the same number, right? So 27 and 9, do they share a common base? In this case they do. 3 to the third power is 27 and 3 to the second power is 9. Okay, so what you can do is you can rewrite it. First, here are the steps formally written out for you. But once you figure out what the common base is, you're going to rewrite it as 27 now has become 3 to the third. And 9 has become 3 squared. After you do that, then when you have one power raised to another power, you multiply the exponents. So you're going to end up with 3 to the 3x plus 1 and 3 to the 2 times 2x. And then you distribute the 3 and multiply the 2 and 2. And then now that you have the same bases, what you do is you set the exponents equal to each other, drop the bases, and just solve for x. So in this case you can subtract this 3x on both sides and we have x equals 3. Okay? They do get a little bit more complex than this, and there are some e's and ln problems that you can do, but just check out the exponential example videos and the logarithmic example videos. But keep in mind also, anytime you want to get rid of an e, you ln both sides. Anytime you want to get rid of an ln, you e both sides. Okay? And again, all that will be illustrated in the example problems. So I hope I've clarified some of the foundational concepts of exponential functions. Please check out the example videos and practice, practice, practice. Thank you and have a nice day.